Good morning. Today we're going to begin lesson 33, which is real life factoring word problems, and we're continuing with some more. So I have a do now. A square has had 5 meters added to its length and 2 meters added to its width. The field then had an area of 130 square meters. Find the length of the side of the original field. So I'd like you to try to figure out what the equation is that we're going to use to solve, and then come back to check your equation before you solve. So if I look here, my original was a square field, so that meant that all of my sides were the same length. And since we didn't know that length, we call it x. Then my length had 5 meters added to it, so my length became x plus 5. My width had 2 meters added, so it becomes x plus 2. And it said the area of that new field was 130. So area equals length times width, so I get 130 equals x plus 5 times x plus 2. So now that you have that equation, I'd like you to go ahead and solve for your value of x. Okay, so looking at our solving, we needed to double distribute, and I end up with 130 equals x squared plus 2x plus 5x plus 10. Combine my like terms, and then I need to subtract the 130 to get it equal to 0. So I get 0 equals x squared plus 7x minus 120. Then I need to factor using my trinomial method, and I end up with x plus 15 and x minus 8. I set both of these equal to 0 and solve, and I end up with x equals negative 15 and x equals 8. Now, x equals negative 15 gets rejected because it's a negative and you can't have a negative length. And x equals 8 then would be the answer that we're going to use. So we need to go back always and look at what the question is asking for. And it's asking for the length of the original field. Now remember, the original field was our square. And the side of the original field is just x. So it would just be 8 meters. So now let's practice with example 1. So example 1, we have a rectangular swimming pool. So the first thing I'm going to do is draw my little rectangular swimming pool. And it says that it's twice as long as it is wide. So if I don't know how wide it is, my width is going to be x. And twice as long means 2 times x. So then there's a small concrete walkway that surrounds the pool. And it's 2 feet wide all around. So that means that from here to here would be 2 feet. And from here to here would be 2 feet. From here to here would be 2 feet. And from here to here would be 2 feet. The pool and the walkway have an area of 160 feet. So it's saying that the whole entire thing has an area of 160 square feet. Find the dimensions of the pool. Well, this one gets a little bit tricky. So the first thing we're going to look at is we need to figure out what my length is. And my length goes from all the way over here to all the way over here. So my length includes the 2 here. It also includes my 2x here. And it also includes my 2 here as well. So 2 plus 2x plus 2, I can combine my like terms, and my length would be 2x plus 4. So now let's take a look at my width. So my width would be from here all the way to here. So my width is going to include this 2 here, plus the x from there to there, plus my 2 to get to the other side. So when I combine my like terms then, my width would be x plus 4. So then we need to set up our equation to solve for the dimensions of the pool. So area equals length times width. So my area is 160. It equals 2x plus 4 times x plus 4. So then we need to solve. We need to double distribute. So I get 2x squared plus 8x plus 4x plus 16. This then gives me 160 equals 2x squared. I need to combine my like terms, 8x and 4x, which gives me positive 12x, and then plus 16. Now we need to set this equal to 0, so I'm going to subtract 160 on both sides. And I end up with 0 here equals 2x squared plus 12x minus 144. So then we're going to look, and the first thing I notice here is I have a GCF. So I'm going to factor out my GCF of 2. And I'm left with x squared plus 6x minus 72. Now I need to do trinomial. So I need to figure out what multiplies to give me negative 72 and what adds to give me 6. So 0 equals, I take my GCF down. I set up my 2 sets of parentheses. I have my x in both, and then I need to figure out what multiplies to give me negative 72, but adds to give me a positive 6. And I realize there that I have a positive 12 and a negative 6. I set each of these equal to 0. X plus 12 equals 0. X minus 6 equals 0. And solve for each. I get x equals negative 12. And then I get x equals 6. Now remember, we're talking about some sort of a length and a width, so negative 12 gets rejected. And I end up with x equals 6. But we always have to go back, look at what the question is asking for. It's asking for the dimensions of the pool. Well, I need to go back now to my let statements. But if I notice, these are the pool and the walkway. So I'm looking at my original diagram, where the length of the pool was 2x. And the width of the pool was just x. So then, my width of the pool is just x, so the width would just be that 6 feet. And my length is 2x, so that would be 2 times 6, so my length is 12 feet. So question number 2, the dimensions of a rectangular garden were 3 meters by 10 meters. So I have this rectangular garden, and I have 3 meters by 10 meters. Both dimensions were increased by equal amounts. Do I know what this amount is? No, so we're going to call this x. And increased by means we're going to be adding. So we're really just going to be adding x to each of these amounts. Then the area of the garden doubled. So if my original garden was 3 by 10, my area of that would be length times width, which is 3 times 10, which gives me 30. So that was my original area. If the area doubled, double 30 would give me 60. So it's asking them, what are the dimensions of the new garden? So I'm going to use my new garden to create my equation there. So my area equals length times width. So then my area is 60 equals my length times my width, which is 10 plus x times 3 plus x. So then we need to solve there. Remember, when you double distribute, after you combine your like terms, you want to put the equation into standard form. So I'd like you to take a minute to solve to get your value of x, and then substitute to get the dimensions of the garden, and come back to check your answer. So when we solved, we double distributed, and we got 60 equals 30 plus 10x plus 3x plus x squared. We combined our like terms, and 10x and 3x became a 13x. Then I rewrote it in standard form, so I had x squared plus 13x plus 30 equals that 60. We subtracted 60 on both sides to set it equal to 0. And I end up with 0 equals x squared plus 13x minus 30. Then we needed to factor the trinomial, and I ended up with x plus 15 and x minus 2. I set each of these equal to 0 and solved. And I got x equals negative 15, which was rejected because it's a negative, and we can't have a negative length or width. And then I got x equals 2. Now we need to go back. Remember, the question's asking for the dimensions of the new garden. So I needed to look at this new picture, and I needed to then substitute in 2 for x. So 3 plus x gave me 3 plus 2, which is 5 meters, and 10 plus x gave me 10 plus 2, which was 12 meters. So those were the new dimensions of the garden. So let's look at question number 3. Question number 3 is more challenging. So the side of one square is 2 centimeters longer than the side of a second square. So that means I have 2 squares here. So one square is 2 centimeters longer than the side of the second square. Well, do I know what the sides of the second square are? No, so we're going to call that side x. Now remember, squares have each side equal in length. So all of my sides would then be x. Now the other square, it says the side is 2 centimeters longer. So that would mean 2 more. So that would mean we're adding 2 to the original square. So the side would then be x plus 2. And since squares have all the same sides, it's x plus 2. Now it's saying the sum of their areas is 100 square centimeters. So now sum means when I add both of their areas, so both of these areas combined would give me 100. So then in order to solve here, the area here of 100 is equal to the area of the first square and the area of the second square. So the formula for the area of the square is side squared. So the area of the first square would be the side squared. So I take my side here because it's area of the first square and area of the second square equals 100. So the area of the first square is side squared. So we take one of our sides, which is x, and we square it. So x squared is the area of that first square. Then the area of the second square is also side squared. So my side here is x plus 2, and I'm going to square that whole thing. So there then I have my equation. So x squared, which is the area of the first, plus x plus 2 squared, the area of the second, needs to equal 100. So now here's something really tricky that a lot of people forget, is x plus 2 squared actually tells you that you need to multiply x plus 2 by itself. So it becomes x plus 2 times x plus 2. And that means that you need to double distribute there. So then I have x squared plus x times x is x squared. X times 2 gives me 2x. 2 times x gives me 2x. And 2 times 2 gives me 4 equals 100. Then we need to combine our like terms. So x squared plus x squared gives me 2x squared. Then I have my 2x and my 2x, which gives me a positive 4x plus 4 equals 100. Now we need to set it equal to 0. So I need to subtract 100 on both sides. And I get 0 equals 2x squared plus 4x minus 96. So now we need to factor, and I see that there's a GCF here. So I'm going to factor out my 2, and I'm left with x squared plus 2x minus 48 equals 0. Then we need to do trinomial. So when we do trinomial, we're going to find that what we need to multiply to negative 48 and add to 2. And I realized that that would be a positive 8 and a negative 6. We solve here and set each of these equal to 0. And I get x equals negative 8. And I get x equals 6. My negative 8, I can't have a negative length, so that gets rejected. So then they want you to find the length of the side of each square. So now I'd like you to pause this video and come back to check your length of each square. When you substitute in for the second square, the first square is 6 centimeters, and the second square, the length is 8 centimeters. So I'd like you to try worksheet number 33 and comment on the video if you have any questions.